116 and 117. Alright, this is page 117. I'm here, if it comes out, you must tell me, immediately, okay? Immediately. Don't make it crawl to me first. Okay, now, can you see, this is a cubic function, right? This is also a cubic function, okay? The below one is also a cubic function, just that the coefficient of x cubed is either positive or negative. We told you yesterday, right? Okay, then we are going on to work example 1. This one, I'm not going to do it in detail. Why is it so dark? Can you all see better like that? Is this better? Okay, wait, this is too far away. Okay. Can you look at this question? Okay, look at this question. It's always phrased this type of manner. Use a scale of 2 cm to represent 1 unit on the x-axis and 2 cm to represent 10 units on the y-axis. Draw the graph of this. Now, when they give you the range, -3 to 3, can you go like that? Okay, but usually the question will give you the table. It's just to complete the table. No? Then you write in the correlating points. Now, actually this one is not necessary. You just need to write x and y category. No need to go and write the whole equation out. Understand? Because the equation is already up there given to you. Okay? So, after this, you will plot the points. And if you look at the graph, I'm going to make it smaller. Can you see you will get this shape? I'm not going to draw the graphs. Can you see you will get this shape? Everybody okay? Now, in graphs, especially at this level, you must label the graph. Because there are many graphs involved in one particular axis. Understand? If you don't label, marks will be deducted also. Because you don't know which one belongs to which one. Is that clear? So, after you draw the graphs, you must label. Okay? Now, then let us look at the question. Okay? Part A, what did they say? Let's take a look at the question. All look up. Find the value of y when x is 1.5 and find the value of x when y is 20. Now, you must draw the dotted arrows. Things that you are reading off and is not in the actual question is all dotted. Understand that? Now, 1.5, can you see is here? You dot until you hit the graph, then you read up. Now, I told you in chapter 1, right? We can only read up to half the smaller scale. Your eyes are not vernier calipers. Understand? Can read to a lot of decimal places. Understand? Half the smaller scale. Now, where is y20? Y20 is here, right? Then you dot like that. Okay? Now, then you please do not forget, after you dot, you must still write down the answer. You cannot dot already and then don't write down the answer. Then people don't know what you're doing. Everybody clear? Everybody clear here? Yes, huh? So, this example 1 is perfectly fine, am I right? Okay, very simple, huh? Okay, now, next. Graphical solution. Now, can we take a look at page 119? I'm going to go through this segment with you. Okay, some people will say it's not really important, but I still want to go through with you. Okay, now all of you look up. This one, I will tell you what it means here because this is what is the basis of adding straight line. Okay, so those who want to talk, right, can get out. You want me to ask the cockroach to go out with you? Then you can talk to the cockroach and tell him don't bother me next time. Okay, come, start. Okay, now let's take a look at this question or this particular paragraph. Everybody look at the box. It's the same as the textbook. No need to worry. It's the same textbook. Okay. Now, to solve this equation, 2x cubed minus 1 equals to x. How would the question be like? The question will be this. All of you look up. I'm going to tell you the question. The question will say, first of all, draw this graph. Can you see this one will coincide the left hand side? adding a suitable straight line, solve this. Okay? Now, can you see this is already the left hand side? So you got to add which line? Y equal to this. Understand? Once you add this line, now this one is a cubic negative one also is something like that. Okay? Y equal to x is something like that. Then the intersection will be the solution. Is that clear? Is that clear? But a lot of things happen. Okay. Sometimes they will not give you sweet or nicely the graph. Okay? You plot this graph. Okay? Then they will say, by adding a suitable straight line, solve correct. Can you tell me, is the left hand side still the same as the original graph? No. No, then how? We must make it the same. How to make it the same? All of you look up. 2x cubed minus 2. How do I get minus 1? I must plus 1 over this side, right? Then it will become minus 1, right? Let's get it all. If you don't want this, right, I can give you a better way. 2x cubed equals to x plus 2, correct? I shift everything over. You can see it, they are still equivalent, right? Then this part, I'll have 2x cubed minus 1. Can you see? I do likewise to both sides. So this will be 2x cubed minus 1 equal to x 1. What's here? X plus 1. Can you see this one is already the graph? So you add which line? You add the other side. You must always make sure the left hand side is the same as the graph that you plot. Then you draw the other side. I mean, very clear? And for your level, right, the other side will be a straight line. Because some people are going to add curves, rubbish. Your syllabus don't have two curves intersect one. Unless we go to trigonometry later in Amex. Understand? Can or cannot? Can, huh? Okay, now then we continue to read. Can you look at this one, huh? You will need to draw y equals to this and y equals to 6, and then find the x coordinates on the points of intersection. Can you see it's exactly what I've written on the bottom? Okay, now then look at the second one, second paragraph. In general, for a single variable equation in x of the form expression 1 equal to expression 2, we need to draw graph y equal to expression 1 and y equal to expression 2. The solutions will be given by the x coordinates of the intersections. Is that clear? Okay, then furthermore, we know that a few ways to decide on the graph to draw. The given equation can be solved graphically by drawing other equivalent sets of equations. Okay, this one don't have to bother because I'll teach you how to do the equivalent set. Okay, now one more thing I want to stress. Let us try another one on this. What if I have this? Oh, look at the one. Original, I brought this. Understand? Original, I brought this. Oh, look up. This is no longer needed. Okay? Can you see? I'm going to transform this such that the left hand side become that. Can you see what I'm talking about here? Yes or no? Yes. Okay. I'm going to write here 2x cubed plus x minus 2 equals to 0. You don't worry so much. You leave the 2x cubed here first. This will equal to negative x plus 2. Correct? And what is this? Minus 1. What is this? Minus 1. 1. So this side minus 1, this side also minus 1. 2x cubed minus 1 equals to negative x. What's the number? Plus 1. Now, can you see this is already the original curve? So I add which line? Add this, the other side. Understand? And a straight line. How many points do you need to draw a straight line? Actually, it's 2. But we usually give 3 because why? We calculate wrongly. Understand? But if you're very confident, 2 points will be enough. Understand? For me, I always use 2 points. I make shall I calculate? Okay, in our lower side, we always say 3 points because we scared you calculate wrongly. Then you have to double check. Is that clear? Is that clear? Okay, alright, good. Next, can we move on to this example 2? Can all of you look at this example 2? This is also rather simple. Can we look at the board now? The variables x and y are connected by the equation this. Okay? Alright? Some corresponding values of x and y are given a table. So they tell you find the value of p. I think it's simple, right? Then after that, using the scale, you plot. Can? 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 So I am going to ask you to refer to your textbook already because I'm going to leave the graph on the board here. I'm going to leave the graph here because I'm going to explain to you what the others means. Okay, can all of you look at part C now? All of you look at part C. The equation, it asks to tell you, the equation minus x cubed equals to 10 has only one solution. Explain how this can be seen from your graph. Now, can you tell me what's the original graph equation? Correct? Yes or no? Yes or no? Yes, okay. So how to see? How to see from the graph? Okay, now, can you look at this one? This is the one that they have given you, right? Negative x cubed. Now, negative x cubed minus 3 will be 10 minus 3, right? Can you see or not? You always take what they give you. Can you see this is what they give you? Then we compare the original. I must have a negative 3, right? If not, I cannot use the graph, right now. So I minus 3 minus 3. So I will get this equals what? 7. Now, do you agree that this one is the original graph? So I just need to add what? Y equals what? 7. Can you tell me y equals 7 is what kind of graph? Like that or like that? Like that, right? Now, can you see, because this is a necessary graph to add, it's a solid line. You cannot draw dotted. It's a solid line, and you must put y equals to 7. Because this represents the equation of the line. Now, how to see that there's only one solution? There's only how many points of intersection? One. Where? Here, right? Can see? So that's how we conclude. Everybody clear? Everybody clear? Okay, good. Now, if you look at the next page, that's what they say. From the graph, the line y equals to 7 only intersect the curve at one point. Or you can say there's only one point of intersection, also can. It doesn't matter. You want? Okay, can? Cannot. Now, so what's the moral of the story? You will go according to the question, then you transform it to the original on the left hand side. This is what you must do. Okay? Alright, now next question. On the axis, on the same axis, write down the x coordinate of the point where this line intersects the curve. One more time. Write down the x coordinate of the point where this line intersects the curve. Okay. That means I must look at this point, right? Can you see it will be here? Correct. Can you tell me the value? Negative one. Oh, I misread the question. Can you see I got to draw another line? Can you see I misread the question? Yes or no? Okay, now, hold first. Can you all look at part C first? The equation negative x cubed minus 10 has only one solution. Explain how this can be seen from the graph. Just now I explained already, right? Now look at D part 1. On the same axis, draw the line y equals to x minus 5 for this range. Okay, now I need to draw this. I'm going to clean off this one. Now, they want y equals to x minus 5. Correct? All of you look up. I'm go teach you how to draw a straight line. You put x, y. A very convenient point to choose is 0. When x is 0, what is my y? Negative 5. Okay? Another point maybe you can choose, because they say the range is from negative 3 to what? 2. So you must choose within this range. Okay? Let's say I choose 2. When it's 2, what's my y? When it's 2, what's my y? Negative 3. So, can you see, you will get this point, then you just have to draw. Okay? Okay, 2 points is enough already. They draw 3 points, so it doesn't matter also. So, you will get this line. Then you must write y equals to x minus y. Must label. Okay? Can? I missed out this part just now. Is it okay? Alright, now, next question. Write down the x coordinate of the point where this line intersects the curve. Okay, that means it's here. This line intersects the curve will be here, right? Can you tell me what's the value of x? What's the value of x? 1, right? It's a whole number. Can you see? It's 1. Okay, now, then the next part is the one that O-level likes to set. But 3. This value of x is a solution of the equation x cubed plus ax plus b equals to 0. Find the value of a and b. Now, what are they talking about? Now, this one is with respect to this context of the question. Now, can you tell me how did I get x equals to 1 when I solve this, right? Alright. Talking to you. This is the left-hand side, which is the curve. This is the line that I've added. Correct. Now, I'm going to rearrange. Agree with me? Okay, I'm going to expand, simplify. Correct. Can you see it becomes like that? Okay, the question say it is a solution to this equation. Ax cubed plus ax plus b equals to 0. I don't know, come in. You don't want to come in also can stand outside. Okay, all together what? I just want to confirm, do you know how I get this? Can I? Because this particular point, you get it because this curve intersect, sorry, this line intersect this curve. So it must be this one equal to this one, correct? So I put equal, then I like that, correct? I expand now. Now you compare. What's my A? Focus. After we do transfer operation, it should be very good in it. After I compare, what's my A? Negative 1, very good. What is my B? B is 2. Did I do wrongly? Correct. I know why I do wrongly. The question say this is, they want it as what? Positive. I want this one only even. Oh my god. This is terrible. Okay, don't worry, I'll rectify it. This is, they want to compare with x cubed plus ax plus b equals to 0, right? Now, you realize that I cannot compare still. Why I cannot compare? Because this is x cubed, this is what? Negative x cubed. But this is an equation. I can multiply the root by what? Negative 1. Okay, so what will I get? X cubed plus x minus 2 equals to 0, right? Now can I compare? Yes, so what's my A? Still 1, right? See, A is 1. What's my B? What's my B? Negative 2. So that's how you compare. Is that okay? Now, the main point I want to drive home today is this one must be the curve, this one must be the line. And you must know what to add. Understand? What to add. Okay. Now, next, can we go on to page 1, 2, 3? Can you see this is the curve for the curve, right? Can you see it? Okay, now all of you look at this particular two graphs here. Okay, all of you look up. Can you see? This is the curve of y equals to a over x, where a is positive. So it can be y equals to 1 over x or y equals to 1, 10 over x or whatsoever, right? So it will go this way. Now, may I know this line whereby the curve approach but never touch is called what? Is there a give it a name? Asymptote. Remember asymptote? What about the y-axis? Is it still an asymptote? Yes. Now, when it's negative, you don't have to worry. You just reflect about what? What's the mirror line? X-axis. You just reflect. That's all. Okay? So, this is the one that is on the 1 over x. Okay. Then, can you look at the next page? Example 3. I'm going to go through all this. Then, I'm going to give you the scale to draw my graphs for Monday. I want to add in the lines. Clear or not clear? Okay. Okay. All of you look up. Everybody look up. I'm going to tell you what's happening. The next person I'm going to call to wake up, and if it's the second time, you'll get out of class. Okay? Now, using a scale of 1 cm to represent 1 meter on the x-axis and 1 cm to represent 5 meters on the y-axis, draw the graph of this. Okay? So, can you see? They give you the whole range, and then they find out the values. Can you see it? Okay? Then, they plot the graph. Okay? Now, from A onwards, I will refer to your question. I'm going to zoom in onto the graph. Okay? Alright, all of you look at the graph that they have drawn. It's like that. Okay, let's take a look at A part 1. The value of y when x is 1.4. All of you look up. This is in your text, don't need to worry. 1.4 is here, right? So you just read. Can you see? Okay? Okay, next part. When y is negative 8. Negative 8 is here, so I just touch and walk and read. Can you see it? This one no need to say because we have done it in our chapter 1. Okay? Next. The equation. This one. The original one is this. The equation can be solved by drawing a suitable straight line on the same axis. Find the equation of the straight line. All of you got. And then to transform this side to this one, right? So this one is very easy, can you see? I just need to put 6 over x equals to what? X what? X minus 1. This is already the equation. So I add which line? Y equals to x minus 1. Can you see? Then I go and draw a table. Okay, now when x is 0, what's my y? When x is 0, what's my y? Negative 1. Very good. What about when x is 4? I get 3. So, 0, negative 1, 4, 3. 4, 3. I can here. Then I get a straight line. Can you see? Understand? You need not do the same points as the textbook, but you will still get the same straight line. Yeah? Can you see they write y equals to x minus 1? Then they say, by drawing this straight line, solve this equation. So, you will read where the line and the curve cuts. Read from your textbook. The line and the curve cuts at where? Cuts at where? What's this value? What's this value? Negative 2 and what? 3, right? Can you see it now? The line and the curve cut at negative 2 and 3. Are you clear now? Are you clear now? So, this transformation can be easy, it can also be difficult depending on the question. Everybody clear? Okay, so that is your example 3. Are we clear? Okay, next, we go on to the a over x squared function. All of you look at the textbook, page 126. Can you look at this particular function? All of you look up. I call this the moustache curve. This is y equals to a over x squared. Can you see it's a moustache like that? Okay, A can be anything, can be 1 over x squared, it can be 3 over x squared. As long as it's positive, you will look at that. Once it's negative, you will go below, because it's reflected about the x-axis. Are we clear? Okay, alright. Then I want to ask one question that I stressed yesterday. Do I go and join with a straight line? No, it's not a volcano. I do not want a volcano. Is that clear? Okay, alright. Next, I'm going on to the next question, and that will be the last example, and I'm going to get you to draw graphs for me, okay? Now, can we take a look at example 4? Can all of you take a look at example 4? Let's on page 127. Can all of you do that? Okay, this one is simple, huh? Using 1 cm to represent 1 unit on the x-axis and 2 cm to represent 1 unit on the y-axis, draw the graph. Then find the value of y when x is 1.6 and the values of x when y is 3.5. Okay, now all of you look up. I'm going to zoom up to the graph. Okay, all of you look. When y is 1.6, the value of y when x is 1.6. 1.6 is here. I will touch, then I rewrite. Correct. Now, why not using the values of x when y is 3.5? When y is 3.5 is here, right? Can you see both directions also can touch? Can you see it? Just like when you have your quadratic graph. Let's say it's like that. Then you have a line like that. Then can you see there are actually two values? Can you see it? So you cannot say I want to go to the right side, I don't want to go to the left side. No. There are two values that are involved here. Okay, so if you read, it will be a 0.6 and a negative 0.6. Can you see it? Graphs are just estimates, but you cannot draw the one that is drawn by drunkard. That means you drink wine and then you draw like that. And I don't want hairy brown also. You are not art student. Understand? I'm not teaching art. I'm teaching maths. Is that clear to everyone here? Yes or no? Yes, okay, very good. So that is our example 4. And I'm going to do 1, 2, 3, 4, 5. 5 graphs. You don't need to do anything else. Just plot the 5 graphs for me. Come back Monday, we will do together. Is that clear to everyone here? Okay. Can you tell me what's the number on the content page? Now I write what? Now I write 18. Huh? Now I write 18, huh? Okay. Can all of you write now 18? Today's day. Exercise 5A. Graphs. Graphical solutions. You need 5 pieces of graph paper. If you don't have, doesn't matter. Take down all. One graph paper. Understand? Yes or no? Okay? Alright, now. First one that I want you to do. All of you turn to page 1 to 8. If your textbook is still closed, that means you do not know what I'm talking about. Okay. First question is number 1. Are you at page 1, 2, 8? Okay. All of you look at question 1. I'm just going to say it here. I'm going to do it for me, okay? The table below shows some values of x and the corresponding values of y, where y is this. Copy and complete the table above, leaving your answers to one decimal place where necessary. Is that clear? Then you look at part 2. Did they give you the scale? Talking to you. Part 2, did they give you the scale? Yes. Then part 3, you're supposed to get the values, right? Can get values, cannot get, never mind. Okay, take out one graph paper. Can I borrow a graph paper? Oh, good. This one, can you put number 1 by the corner here? Then I want you to turn to the back of the graph paper. can you write this? This is question number 1. Okay? Question number 1. Go to the back of the graph paper. Can you write down this equation? Now, I'm just giving you instructions. No need to do it now. You draw the table and fill it up. Understand? Then, what is the scale that they want you to do? The x-axis. The question says 2 cm to 1 unit. How about the y-axis? 4 cm to 5 units. And the x you must draw from -1 to 4. And the y you must draw from -5 to 20. That is your question 1. You just need to draw for me. Would that be okay? Scale or given? Okay, I can give you 1 minute to tidy up. Question 1. Repeat. Just need to write the equation, complete the table, use this scale to draw the graph, that's all. The rest of the question will come back on Monday. Everybody okay? That's question 1. Next one. Take out another piece of graph paper. Question 3. Are you okay? Can or cannot? Can or cannot? Can, huh? Okay. I'm moving on to the next one. That is question number 5. Using a scale, the question says using a scale of 4 cm to 1 unit on both axes, draw the graph of this and then find the values. Now, can you tell me what is so no good about this question? Did they give you the table? They didn't give you the table. So we have to come up with the table. Is that clear? Now I'm going to come up with the table for you because you need all these points in order to draw a nice curve. 0.5, 1, 1.5, 2, 2.5, 3, 3.5, and 4. You need to fill up all the space. Okay? This is third graph paper. The fourth graph paper. Okay. This one is also not a very kind question. Why? Did they give you the table? No. Take the scale? No. Okay? Now I'm going to give you the table. Okay. Can you write this down? Just need to draw the graph. No need to do the rest of the question. Understand? Cannot. You need to have the basic graph in order to start on Monday. Okay? So I just give you like that. You just copy and then after you draw. That's all. The homework for today is just like that. Okay? Last question. Last question is question 11. Okay. Table also not given. I'm going to give you the table. But the scale is given. Okay. I'm going to give you the table. Question 11. Fill in the blanks. Okay. Okay, I'm going to write big on top. Okay. Can you see the red numbers on the bottom? I'm just going to say one time and then I'm going to let you do the rest. Okay? All of you stop writing and listen to me. I'll give you the rest of the time to do it. 1, 3, 5, 9, 11. Each question on one graph paper. The basic graph must be there. Then Monday, I can add in the appropriate lines. Is that understood? Okay, you must join all the points. Is that understood? Okay, how many graphs to draw? 5. Must you answer the rest of the question? No need. But if you want to try, you can. If you don't want, doesn't matter. Monday comes, we add in the lines. Is that understood? If I do not have the basic graph, I cannot add in the lines. Is that clear to everyone? So the only mission for today, Saturday and Sunday is draw all 5 graphs. That's all. Everybody clear? I already given you the scale. Yes? Okay, Alvin, stop the video. You can start drawing now.